So for my one real root example, I chose to go down. It doesn't really matter. You can have one real root when your parabola is going up. I chose the equation y equals negative 2x squared plus 4x minus 2. Now if I was to factor this out, you would see that I would be able to pull out negative 2. More importantly, you would see that I would have x minus 1 quantity squared. So by pulling out the negative 2, this would have been the remaining piece would have been a perfect square trinomial. That's a key element to having one real root. Again, I would set both of these equations equal to 0 because you can't really solve a problem without having a number to equal to. And so at this point, the only possible root, just by looking at the factoring, would be when x minus 1 equals to 0, which in this case would be x equals 1. Now remember, negative 2 can never equal 0, so this piece is kind of irrelevant. Again, the focus isn't so much on the factoring, it's on the graphing. As long as I can graph it, and I can see that it crosses the x-axis in one spot, which would be right here, you'll see that I have specifically one unique root of in this case, the number 1. I can see this again if I actually go over to my graphing calculator, type in my expression, which I did, go over, hit graph, and what you will see is you should be able to see. Now, the problem with graphing calculators is it's with the pixels being quite large and not having great accuracy, sometimes things look like they're crossing. So the best bet is to double check by going to second calc. Go choose option number 2. Now in this case, I could go left bound, right bound by using my arrow keys, but let's be clear here. I think the easiest thing to do is I know my answer is supposed to fall at 1. So if I choose numbers, let's say 0.3, and hit enter, and maybe I go to 1.7, my interval will fall between, my interval will cover the single point. I should be able to just go ahead and hit enter to guess, and you will see once again that my solution comes up as 1.000006, which we've already discussed is pretty much means it's just 1, and then the y-coordinate is 0. And so that is my one solution. Now again, with the extra decimal, sometimes that does wonder if there's actually a second one in there. I don't really have any great suggestions for that. That's why, except for going back to maybe looking at the factored form. But usually in these cases, we're not going to go out of our way to try to intentionally trick you. So that's the second possibility, one real root. Okay, if it's shifted over slightly, it could be an irrational number, or it could be a rational number. So for my third example, we're going to graph y equals x squared minus 3x plus 4. There's the parabola. Setting y equal to 0, you will notice that this graph never crosses the x-axis. If I would come over to the graphing calculator and hit graph, you'll notice that I've already graphed it ahead of time. I'm not able to see it ever crossing. On the off chance you just don't feel comfortable, maybe you want to see a little bit more, I don't know if I'd hit zoom out. Maybe I'll change my y max to 7, and you can see a little bit more of the graph. Okay, so still doesn't seem like it's going to cross the x-axis. What would have happened if I actually would have gone down to 0 and chosen a value? So let's say I'm going to go back left over here. I'm going to hit enter. Now remember, I don't have to keep hitting the arrow key all the time. I could just say, you know what, let's go to x equals 4 and hit enter. Got a big giant interval here. Come on, tell me what my guess is. And in this particular case, it will tell you no sign change. Now, you get no sign change anytime you pick an interval that does not have a 0 in that time. Now, if you incorrectly pick an interval, if you pick your interval wrong, there could still be a root maybe outside the interval, but in this particular case, when I go ahead and hit enter and actually look at the graph, there's no possible way. So, normally, we would say this is 0 real roots. But in actuality, we can solve this equation because if we examine, again, that quadratic formula that we're talking about, you're going to see that I'm going to take a square root of a negative number. And when you have a square root of a negative number, you actually are going to get imaginary roots. Okay? Now, when it comes to graphing, I'm not asking you to tell me what the imaginary roots are. I just want you to say no real solutions. When we get to the next part where you are solving by the quadratic formula, then I'll expect you to be able to tell me what those imaginary roots are. So, recapping again, There are three possibilities. Let's see if I can recreate them very quickly. Let's go 3x and 2. You will have two real roots. They can be going, the parabola's direction of open can be going up. It could even be going down. They could be positive, they could be rational. They could be irrational, like these ones here. I could have one real root. Let's set this back to 1. Let's go to 4 here. Let's set this to 4 there. You'll notice I have one real root right here, crossing specifically at -2. And if I would just push this up ever so slightly, I would have no real roots, and they would be two complex roots. And again, you could have this parabola going down, and with a little bit of shifting, let's see if I can get it. There you go. No real solutions. And that's pretty much it. Oh, let's slide that over a little bit so you can see the whole thing. Those are the three possibilities.